Hi everyone. I'm so sorry that I've been gone for so long. I know one of my goals was to post more frequently, especially with the start of the new school year in September or like August for some of you guys. I really just want to post like maybe a couple of videos every week or maybe three, but unfortunately over this past couple weeks, like an immediate family member was kind of sick. And so I've been really busy with that plus school and work. And I just didn't have enough time to do this, even though I really wanted to post more videos. But now I'm back and hopefully I'll be posting much more frequently. But no promises. I'll really try though. Okay, so I have with me here problem 3.27. This is actually kind of a really easy question, to be honest. And the reason is because it's circular motion, and circular motions, they're very predictable because they have just a couple of like equations that you just have to memorize, and that's really how you solve most of their problems. So they're not like too involved, like I guess how projectile motion questions were for 2D in 2 dimensions, and then or even how not relative probability, but like how relative motion was. I don't know why I said relative probability. Sorry, my mind is everywhere. Anyways, the point is we did a ton of 2-dimensional projectile motion questions, and we definitely kind of established a pattern and how to solve those types of problems. We also did a couple of relative motion questions, but we didn't do any circular motion questions. And so I thought, why not do maybe at least one example so that you can have kind of a comprehensive view of how to approach these problems, how to think about these problems, get exposure to some of the formulas, and maybe when you see kind of a couple of these problems, you won't really have to do too many to kind of understand how they work. So yeah, I just wanted to include one of these for the sake of your understanding. Okay, so let's get started on this. A Ferris wheel with radius 14.0 meters is turning about a horizontal axis through its center. The linear speed of a passenger on the rim is constant and equal to 6.00 meters per second. What are the magnitude and direction of the passenger's acceleration as she passes through A, the lowest point in her circular motion, and B, the highest point in her circular motion? How much time does it take the Ferris wheel to make one revolution? Okay, so before we get started with the actual problem, let me actually go ahead and do like a quick like tutorial, I guess, for how relative motion works. Okay, so not relative motion, I'm so sorry again, how circular motion works. Okay, so there's a couple of formulas for this, and there's a pattern to how this works. So, you know, let just for understanding, let's do a really quick crash course from the very beginning. So if we have circular motion, it's going to look something like this, right? Okay, I don't like that circle. I'm going to draw that again. I hate that circle actually, so hopefully it sounds better. Okay, much better. And let's say that this is the direction of the motion, right? So that arrow is the right direction that the object is moving. So it's kind of moving like in this way, right? Okay. And we know that this is 2-dimensional because if it were 1-dimensional, it would just kind of move up and down or right and left, and that would make it 1 dimension, right? So even though it's moving throughout like one line, that doesn't necessarily make it 1-dimensional. It's 2-dimensional, right? Because if this were X and this were Y, positive X and positive Y, we can see that it's in 2 dimensions, right? And when we have circular motion, right, we have acceleration and we have some velocity. And again, there's a pattern to this, right? So how does acceleration look like in circular motion? What direction is it, right? Because in projectile motion, we said that, you know, most of the time on planet Earth, it's actually always on planet Earth, or most of the time. I don't know if there's some like obscure example out there, but you know, in every single problem that we did, right, I should say it that way, every single problem that we did, acceleration was just downward, right? So at every point, it just pointed down, right? And speed was just, you know, the direction that the object was at that point in time. Okay. So what about for circular motion, what is the direction? Okay, so let's illustrate this. Let me change my color. Okay, this Zoom toolbar looks a little bit different. I haven't I usually do all these tutorials on Zoom, and I haven't done this in a while. So it's looking a little bit strange. Let's see, how do I get a color? Oh my God, they have the color pink. Okay, I love the color pink. Let's use pink. Okay. Oh my God, I only had like four colors of choice for when I used to do this before, but I'm so glad they have the color pink now. Okay, so if we have velocity, I'm so sorry for going on a tangent, but yeah, if we have velocity, it's going to, so if this is the direction, right, velocity is going to move this way. Oh my God, this is such a pretty color of pink. Sorry. Okay, so yeah, we have velocity at every single point. Velocity is going to be tangential, right? But then acceleration, it's always going to point towards the center, right? So that goes for any other time. That goes for any point in this like circular motion, right? So let's try that again. They have purple. Let's do that with purple now. So let's say this is where the object is, at this point in the circular motion. The speed is going to point outwards, right? Just like that. And then acceleration is going to point in just like that. So that's going to be the direction of the acceleration, and that goes for every single point. So at any point in this circle, the speed is tangential and the acceleration points towards the middle. And that's just how circular motion works. It's not really going to change. So that's our quick crash course. Okay, so now let's get to the actual problem. Okay, so let me change my pen color again. So what do we know in this problem? What are we looking for, and what do we know? So we are looking for passengers' acceleration and lowest point at the lowest point in her circular motion and at the highest point. So what does that mean? We're looking for acceleration like right here and right here. Okay. And what do we know? Let me do this in pink because pink is my favorite color. Okay, so what are our knowns? We know that the radius of this Ferris wheel is 14.0 meters. And then the linear speed is constant and is equal to 6.00 meters per second. Oh my God, my foot's asleep. Okay, that's okay. Almost done this problem. Okay, so yeah, a speed is 6.00 meters per second. And what we're looking for is acceleration. Okay, so these are our knowns, and this is our unknown. This is what we're trying to find out. Okay, so again, what's great about circular motion is that we know what the what's it called? The formula for the acceleration is going to be, right? So this is the formula. You know what? I'm gonna use the color purple. Okay, so A is equal to V squared over R. Oh, that's so pretty. Okay, so V squared over R, and we're given V, right? So V is 6.00 meters per second squared over 14.0 meters. And what's that going to be equal to? Plug it into our calculator, right? And I'm getting 2.5714 meters per second squared, right? Yeah, so we have meter squared, second squared, and then this meter cancels out with, the square on top of that. So then we just have meters per second squared. Dimensional analysis, which by the way is so helpful. I had my board exams a few weeks ago, and I can confidently say that. Sorry, I'm gonna cough for a second. Dimensional analysis will get you so far in I think any like physics type test or exam, just because sometimes even if you don't know the formula for something, by like writing out all your knowns and seeing like what cancels up with what, you can always somehow like figure things out, right? So if they're asking for acceleration, right? So how can you cancel the units for speed and radius to get acceleration, right? So that's one way to memorize formulas, to kind of drive them and figure that out, right? It's really intuitive. Okay, so yeah, that is our acceleration. Now, in which direction? So we know that the acceleration, because the radius throughout this entire Ferris wheel, right, it's not changing. It's not 14 meters at one point and 17 meters at another point. It's always 14 meters. And it says that the passengers on the rim and is constantly and equal to 6.00 meters per second, or like moving at that. They're not equal to that number, but they're moving at 6.00 meters per second, which means that if our values aren't changing, then our acceleration is not changing either, right? So our acceleration, both at the bottom of the Ferris wheel and at the top of the Ferris wheel, are going to be 2.5714 meters per second squared. So now all we really have to do is figure out the direction of the acceleration. So again, because this is a circle, we know that the acceleration is always going to point towards the center. So now let me use a different color. Okay, let's use this blue. So when we're right over here, we know that acceleration is going to point towards the middle or the center. And when right over here, it's going to point towards the center, right? And if we were here, it would point towards the center. And if we were here, it's going to point towards the center, right? So at any point, we know that the acceleration for circular motion is always going to point towards the center of the circle, right? So at the bottom, so if we have A, lowest point in her circular motion, the acceleration is going to be 2.5714 meters per second squared upward, right? And then B, 2.5714, because we said that the acceleration isn't changing because the speed and radius aren't changing, is downwards, right? Because it's pointing down. I'm obsessed with these colors. Thank you, Zoom, for this new update. Okay, and then C, how much time does it take the Ferris wheel to make one revolution? So to make one revolution, again, we're going to be using one of our formulas, right? But instead of me just giving you the formula, let's try to kind of derive it almost on our own, okay? Sorry, I just want to see the time. I really hope my laptop doesn't shut down. So hopefully, you know what, let me pause this really quickly. Sorry, I just plugged my laptop in. I hate recording things twice. So yeah, hopefully this will be fine. Okay. All right, okay. So now let's talk about how much time does it take? Okay, so time, how do we derive that? So let's go back to, let's use a new color. Okay, let's do, actually, I don't want to use a new color. I want to use pink again. Okay, so B, right? So we want time, right? So, and we have speed and we have distance, right? So time is equal to, or sorry, if we have distance, that's equal to speed times time. So time really is just equal to distance over speed. Okay, so well, what's the distance? In one revolution, this is the distance, right? This entire circle. So the circle, it's going to be the circumference, which is 2 pi r, right? And then the speed, well, they gave us the speed, it's 6.0. So let's do that again. It's going to be 2 pi r. I don't know why it's doing that. Thick letters, but whatever. Okay. 14.0 meters. And then 6.0 meters per second. Okay. So when I plug all of that in, I'm getting 14.66 seconds, or, you know, approximately 14.7 seconds. So that's how long it takes to do one complete revolution. It takes the Ferris wheel to do one complete revolution. Okay, so that's the end of our question. That's the end of our problem. We got A, B, and C. So yeah, that's it. I hope this is helpful. And if you have any questions, as per usual, please feel free to leave them in the comments or send me an email. Thank you so much for watching. And if this is helpful, please don't forget to like and subscribe. And see you next time. Bye.